I want to introduce Rick Mugridge from all the way New Zealand. Rick has the crazy idea that we can talk about tests and can define tests when we talk about features, and he developed a couple of tools for it, and he will talk about this today.
Thank you, Mark, and good afternoon. Pleased to be here. So I'm going to be talking about Fit, which is an open source framework, and I'm going to start by talking a little bit about that, which will give you a bit of context before I start tackling the issues that have been raised. So how many people here are already familiar with Fit? Okay. And how many of you are interested in tests and or test-driven development? Okay, great. So if I talk about anything you don't know about, please just interrupt me. I'm happy to take questions at any point. I've got some material I'm going to skip over because it might come in handy, and I always kind of make it up as I go along a bit, so please bear with me. Okay, so we'll start by talking about Fit, and as you can see, I've written a book about that with Ward Cunningham last year, so this is my advertisement, I suppose you could say. So Fit was developed in 2002. At that time, I'd been working on agile software development. I generally work in agile software development, although the things I'm talking about today can be applied outside of that context, although some of the thinking comes from that, and you'll see in my presentation I'm kind of assuming that. So Ward developed an open source framework which was very powerful. At the time, I developed a few frameworks and I wasn't very happy with them. And I shifted over to using his, and then I started doing further development on top of it. So Fit is available on the web, available in lots of languages. It's based on a very simple notation that's kind of doesn't look very formal, and this is tables, as we'll see shortly, and those tables are a way of expressing requirements and or tests. Now, one of the things I'm going to lead to in this talk is to start by thinking about these as being tests, and by the time I finish, I want to talk about them as being requirements, executable specifications. And so we're going to switch things around. So it's about testing, and it's also thinking about and a way of specifying what a system should do. So it's not necessarily a back end, something that happens at the end of the process. It's something that happens all the way through, right from the start. So these tables initially were HTML was used. It's a very simple format, and the data in the tables is essentially interpreted in a very general way. So Fit is, if you're familiar with domain-specific languages, it's a table-based, very general-purpose domain-specific language. There are a number of tools that have been developed. Fitness is a wiki-based tool. Ward developed a very simple one. This was developed further by Micah and Bob Martin, and this is probably, especially in the US, is the main tool that people use for developing it. I've done a lot of development on top of Fit, which I call FitLibrary, and which is used extensively as well and has been ported by various people into a range of languages. So just very quickly before I show you some examples using Fitness is here are 4 separate, very little tests. So they don't give you much of a sense of what a story test will look like. I call them story tests. For good reason. Well, I'll come back to that later, but they're not just a test, they're also telling a little story as a concrete example, and in this way they act as a kind of specification. This one here is a very simple workflow which is specifying a trace through the execution of a system and is showing here is some initial context, here are some actions that are carried out, and this is what we expect at the end. Some other kind of tables, this is representing an invoice, and which is laying out information. The parts that are green, these are actually reports from the test having been run and showing that the test has passed. And as with JUnit or NUnit, the red-green colouring is used to signal that something's correct. As a programmer, which is primarily what I am, I now don't feel happy until I have a lot of green and I don't really feel like doing anything until I have a bit of red. So that's kind of my attitude about writing a test and developing to pass the test. So the top table shows where something is not correct, something hasn't passed. Either the test is wrong or the system is wrong. Because the best we can do is we have two representations of a system and we're checking them for consistency. And it's just as easy to make mistakes in the tests as it is in the code. Within FitLibrary, I've added the capability of going beyond plain text within the tables. And here's a simple example where a graph is represented as it happens by dot. And the tests can then be more expressive around a graphical structure. Okay, so what I want to do is show a little bit of this in action, and let me make this bigger. So this is not going to display as well as it might because I've upped the resolution. Can you see that at the back? Is that enough? Okay, so here's an example of a simple business process, and it's similar to the one we saw on the screen. And so in Fitness, I can edit that by editing an underlying wiki format, which looks like that. So it's relatively straightforward to get into. For people who are not programmers, who are not used to technical stuff, some people don't like this as a notation and would prefer to use HTML. But essentially, that's what the underlying form is like. And I can run that as an individual test, and as you can see, the test is passed. I'm getting green. It's possible to have a set of tests which make up a suite, and here I've got a suite of things, and I can run that set of tests as a suite. Now, once the set of tests build up, I have a large set of suites of suites, and I want to be able to then run these story tests in a lot of different ways. So the same story tests, when I run them and with slightly different configuration, may test the system at the domain layer level. It may run into the different subsystems. It may actually test through Selenium into a web-based interface, or it might run through Swing or some other GUI. So the story tests are somewhat abstract representation. If you're familiar with use cases, they're equivalent to the notion of essential. The essential part being not too much detail about the fine-scale interaction. And their power really comes when they are not too specific about the finer detail. And I'll say something a little more later about how a mapping is made between the abstract form of the story tests and into a particular testing scenario. Now, as I mentioned, I've been developing FitLibrary, which is an extension of Fit. And of course, the way in which I do that is the same kind of process. And so I have a set of specifications for FitLibrary itself. And so I can develop those and make sure that whenever I make changes, that I don't break anything. Now, I've just done a major refactoring of the library, and it's wonderful to be able to make a change, run all my tests, and know that nothing is broken. Well, almost nothing. So I'll just show you that this can happen on a larger scale. There's a large number of tests. This is just the test for one of the so-called fixtures, and it's both a test and a specification of what happens. And so this doesn't look very nice, but what we see is on the left-hand side is a table, and this is the table under test, and on the right-hand side in this is what the report should look like. So I specify in a pictorial form what should happen within FitLibrary under these various circumstances. So there are a whole set of little programs and story tests which together define the behavior. So I'm going to switch back to PowerPoint now. I can get my fingers working. And so that gives you a bit of an idea of Fit, a very brief one. Now, as I've worked on this, I've realized that the process of designing tables and of evolving them has got some things in common with programming. Most people who use acceptance testing tend to write tests at too low a level, and there's a lot of redundancy. And when the UE changes, then lots of tests break. That's a kind of standard problem. So obviously, there are kind of issues around avoiding redundancy, having the right forms of abstraction, what are the patterns that you use for writing these, and so on. And some of those are covered in the book, and I've been developing those ideas further. But one of the fundamental things is, what is the best way of expressing this as concisely as possible so that it's possible to see, are all the cases covered? For example, if we have a lot of workflow, and again, this is a common smell for people who write tests, is to write a lot of workflow tests which then are repetitive with small differences. So there's an extraction process which can take the essence of those different workflow and pull out the differences and express them in a clear form. And that then is being precise, usually about business rules which are encoded within that system. So I see the process of developing story tests as a process of being clearer about the business rules underlying the system and the way in which it will work, and finding ways of expressing those very succinctly. Now, when I work with clients, working with business analysts on doing this process, it's interesting that in going through this, people begin to notice things they've never noticed before because they've not had a way of expressing and focusing on the important elements of the domain. A few weeks ago, I was working with a client where the business analyst was saying, look, we've had ongoing problems with this feature. It doesn't seem that complicated to me, but I'm finding it really hard to communicate this to the programmers. We sat down and wrote some very simple examples, starting with a very simple one, and developing it step by step. And there wasn't much to it, really, and the examples just came out really clearly, and everyone was surprised. They thought, well, we thought it was more complicated than that. Now, underlying all this, then, is the notion of writing examples, concrete examples which are meaningful. So the more meaningful they are for the domain, the better it is for the programmers. I know for myself as a programmer, often I'm working on something and I'm not sure who the users are. I'm not sure what the business context is, and I'm missing out on that detail. So the examples can help with that. The other thing I notice is that by starting with simple examples, then people start to make explicit the assumptions that they don't normally mention. So it's quite often the case that you find partway into the development of a system that no one has mentioned something really important, like access rights, or money, or performance issues, or anything else. So finding ways of starting very simple with simple scenarios seems to be very important in this. I don't know about you, but all through my career, I always see the development of programming, a program of inventing an example which pushes outside the bounds of what I'm doing. What is an example now which will push me from here as at a kind of a modeling level, here's a one-to-one association. So there's a question to the project manager which is essentially asking the question, is this a one-to-many or a many-to-many relationship? What are the constraints on that association? And then what is an example which expresses that and pushes the boundary? So I see kind of design in that model is very similar to the scientific process, which is saying, here I have a theory and I want to explore the theory, the consequences of it. What is an experiment which will allow me to identify and show that I'm right in my theory, and possibly show that someone else's theory is wrong? So that's kind of pushing around the edges of an idea. And the same thing I think applies in design. What are the way in which we can push the ideas and generalize? And often part of what comes out of that is that you get a collapsing of a lot of different ideas into something that's much more powerful. Okay, so I've hardly got beyond. So that gives you an idea of fit and a kind of general attitude about story tests. Now, the advertised issues are somewhat. Well, Mark, thank you for bringing those together. These very nicely kind of get at some of the issues that story tests begin to help provide a solution for. As I'm sure you know, there are no silver bullets or gold bullets or whatever, and that these are things that might help. So what I want to do is have a look at each of these four issues. How do we deal with a legacy system? And how do we do that in such a way where we don't want to slow down its evolution? By legacy, I like Michael Feather's view of legacy. What legacy means is a system that essentially is not supported for evolution. So it doesn't have tests. It's not easy to make changes because, well, people start getting worried about changing it because things will break. And so it becomes solidified. So legacy to me means not able to be changed easily. So the next issue is, well, we have a great application that's got a neat UI, then how do we supply a program access to it and lots of different technologies underneath? The next one is QA tends to happen in most shops at the end of the process, and oftentimes that's, there can be quite a delay from when a problem has actually been entered into a system. It may be a misunderstanding, it may be a bug or whatever, until it's found. So how can QA be involved earlier and more effectively? And then finally, how can project managers, BAs, product managers and the like, how can they get involved and utilize their expertise in this process somewhat more than often happens? So I'm going to look at, and I've kind of covered some of this already in terms of giving you an overview of that story tests act in each of these cases, starting with a testing perspective and heading more and more towards a requirements perspective, which is what is it that we want rather than is it what we've got, what we want. I'm a great fan of carpets and their geometric design, and they kind of, I've always wanted to be able to use tables that look like carpets, but I haven't managed to come up with a way of having some beautiful object represent a test yet, so maybe in time. Okay, so legacy system providing test coverage, how to improve that, but also to allow for evolution. So what's the fundamental problem? If it's a legacy system, it's not test infected, it's not easy to be able to make changes to it because you might break something. It's often easier to add more code rather than to refactor what's there, and so you lose out on building abstraction. So there's a catch-22, and I understand Michael Feathers was here talking about working with legacy systems, and essentially the catch-22 is that you have a system and that once it's test infected, then it's very powerful as a means of, you have the support to move forward, but on the other hand, in order to add the test infection, it thoroughly changes the code. If the code is developed test first, then it ends up being in quite a different shape than if it is, we're adding test afterwards. So Michael talks about various techniques that can be used to gradually do test infection. And I think a fundamental principle of that is, in a large system, it can take quite a long time to do that. So it's a matter of just by need, as parts are being changed, to then start working on them. Now, as I see it, that story tests can support that. And if the story tests are written very much in terms of what does the user do on this user interface, or what are the low-level details of the protocol between machines, or whatever, then the story tests may be useful as tests, but they're not so useful as in terms of helping the domain and helping the evolution of the product. So by focusing on the essence of the domain, and as we'll see as I move on, I'm going to make a case for using story tests as a way of doing domain-driven design. How many of you are familiar with Eric Evans' book on domain-driven design? Okay, so that kind of fundamentally, I think there's a very nice fit between fit story tests and a domain-driven design as an approach. Okay, so the standard approaches are manual testing. Record and playback techniques have been in use for a long time. They tend to not be that great when a system changes because you tend to end up, well, many of these systems have weird scripting languages. I apologize to anyone in the audience who's Thai, but I just wanted something that most people wouldn't know how to read as a kind of a little example of something that it's hard to interpret. So I think it's actually quite a beautiful script. So it's possible to manually test and it's surprising to me how many organizations only manual test and can't test very much. Automated testing, most people test at the user interface level. Tends to be slow, the tests are verbose, they're hard to manage, and so on. So verbosity, repetition, hard to alter. So much detail, it's hard to see what's going on. Because it's traces of the system being executed, it's very difficult to see the abstractions. Pull out, there's a kind of no notion of what is at the heart of the system, which usually is a domain. And usually the things that are interesting and that are long-term are around the domain. Of course, there's going to be a lot of technology supporting that. So kind of by analogy, Roman numerals are great in some ways, but are really poor in others. Like doing arithmetic on them is not very easy. And likewise, from a programming language perspective, then the way in which programming languages have evolved are towards higher levels of abstraction, finding brief ways of talking about things and so on. So that they're the same kind of issues underlying this, which are around avoiding repetition and finding abstractions, finding good ways of expressing things, but without using a programming language. Okay, so the next one is in terms of providing program access, and the only kind of techniques I've seen, so the problem often happens is that many applications are written with a tangle between what are often can be seen as separate layers. And I think there's a clear indication that in complicated systems, having clean layers is a very useful thing. And these will very much come out when test-driven development is being used. So I take it from this issue is that there is a system that's been developed, but there aren't clean layers, and it's then difficult to provide programmatic interface into the API, provide services. So there's actually lots of good reasons for separate layers, as you probably know, including modularity, being able to plug in different user interfaces into the same thing, clarifying the domain in the domain layer, and providing programmatic access into that. So there are various techniques that can be used. I've seen people try and use automatic translation techniques and trying to abstract stuff out of the UI, but I think it's incredibly difficult. It's kind of like dumping all the UML diagrams for a system and then trying to make sense of that UML. Usually it's not very helpful unless you can really filter it out. So one way is just, duplicate the code, but then duplication is bad smell. Pull out a service layer, it's very procedural, or kind of focus on that domain layer. So I'm kind of looking at the same solution really, which is be clear about the domain and move towards supporting that domain layer, pulling it out, and so that programmatic access can be supplied in that process. And at the same time is a clarification around the domain. Now I talk about clarification around the domain. I find it quite difficult to give good examples of that because often the examples arise right within the context of the way in which, for example, when a client of a utility doesn't pay, then what is the process that happens so that warnings are sent to them and there's various steps involved. Out of all of that kind of business detail are some clarity that comes up around the business rules, but it kind of makes sense to the people in that context, but not outside of it. Eric talks about, in his book, about clarity around the domain, which was the programmers assumed that shipping containers around the world, you would have objects for containers, for ships, for ports, and so on. And it took them quite a long time to realize the fundamental abstractions were not at all around that. It was all to do with passing responsibility and the legal responsibility for the goods as they went from one part to the other. So once the focus shifted towards that documentation and legal responsibility, then a whole lot of things made sense. And I'm sure all of you have gone through the process of, there's kind of a frustration that builds up. You're trying to understand something. You're not quite sure where to put it in the code. It's not making sense. And then you one day just realize if you look at it, you cut the world up in a slightly different way. It all just, suddenly it's so much easier and it's kind of relief. You feel it in your body and you move forward on and you go really fast for a while. Okay, quality assurance, getting QA involved earlier. Well, this is all about feedback. If you imagine that you've done something a year ago and only today have you found out that you made a mistake, you go, wow, I can hardly remember the details of that now. Well, I would feel that way. There's so much that I've done in the meantime. If you scale that down to a week, it's not so bad. Down to an hour, it's not so bad. And down to a second, it's utterly different. And it's to do with, if you're in the context of doing something and you're getting very fast feedback on that, then you can respond immediately. So there's much less effort involved in tracking down the problem, getting back into the context of finding a solution and making it happen. So the average programmer, every time they fix a bug, there's a 1 in 6 chance that they will, yes, that's right, 16% chance that they'll make a mistake. So I'm kind of assuming that if the feedback is faster, then the chance of making errors is going to be lower. And then if there are test-driven development, story test-driven development, those things are going to be picking them up much faster. So bringing the QA earlier in the process is a good thing. And the earliest you can bring QA is right at the start. Now, in an agile approach, you don't try, in a waterfall approach, I suppose you would kind of say, well, we'll write all our tests before we do any programming. And that kind of sounds a bit daft because there's huge numbers of decisions that are going to be made around writing those tests. So an evolutionary approach is to say, let us write some tests for the next iteration of the system, and then the programmers, the developers are going to then work using those tests to then develop the code. They know when they're finished, and the tests continue to build up, and they act as the framework for making sure that things aren't broken. So these tests then turn more into, at the overall system level, in terms of thinking about requirements, and at a programmer level, more at a level of design. And so there's a kind of a counter to that testers do anyway, and there still needs to be activities at the other end. So as parts are finished in a system, exploratory testing, namely you play around and try it out, is something that has to be done because it's always easy to make mistakes. Testers are very good at thinking about, well, what happens if I put a really large number in here? Or what happens if I hit this kind of strange key sequence, or I do things in this with a speed or whatever. So there's kind of an interesting interaction between talking about a system and what it should do, and also the tests. Okay, so one of the few things, there's not much that we have a lot of evidence about in software development. There doesn't seem to be any evidence at all, and from an experimental point of view, that OO is any good, that UML is any good. There are a few things that we do know. We know that inspections are helpful in some form, and there are a lot of ways in which inspections can be done. The other one that seems to be pretty sure is that if there's a focus early on quality, then you can actually go faster. If you try and go faster and you end up with poor quality, you go slower. So, and this has come about through, people have tried this in lots of different ways. Okay, so how I see QA fitting in is that the testing perspective, as well as we'll see shortly, the business perspective, the design OO perspective, the modeling perspective, all joined together up front and coming up with story tests. So one of the things about writing the story tests, the concrete examples, you communicate them with people, you actually start and have building a language for discussing it, and they provide very fast feedback. So if there is differences of opinion over what should happen, then you may find them earlier. Like I was working with a group of product managers, and I was showing them how to write story tests and getting them writing story tests, and two of them said partway through, look, it was just amazing that when we sat down together and started writing the story tests for the next system, the part we're working on, that we understood it completely differently. And we never realized that. We've had lots of discussions about it, but when we sat down and wrote an example, then we began to see that we had differences and we were able to resolve those now rather than much later on. So basically, bringing in quality and thinking about what's needed much earlier. And this leads to the final point, issue. And as you can see, I'm skipping over these. I'm not really saying a lot about them, is that how can product managers provide their expertise more earlier? Writing requirements. Well, the requirements engineers say, well, if the project doesn't go very well, then put more effort into writing the requirements. Doesn't seem to work. It's very, very, very hard to write general statements in English and have people understand them. It's hard enough writing general statements in a programming language for others to read. So requirements tend to be a problem, particularly if they all have to be written up front when it's not at all clear what is going to have the best value in the system. So there are issues around what is needed, what is the business domain, what is the return on value, return on investment in different approaches. So if we're talking about requirements, then how can we express these in a form that will help communication between all of the various people in the team, help clarify and build understanding around it, help build a sense of the domain, and also, as a secondary thing, act as tests to tell the developers when they're done and to tell the developers that they've broken something that was already done through the process of building up story tests. So story tests then can act as a way of developing requirements as executable specifications and support the domain-driven design idea of developing a ubiquitous language which is talking about the domain. So where does that language sit in the tables? It sits in the tables in terms of the names of columns, the names of the words that are used within that, which start to get clarity. So again, when I'm working with people who are product managers and the like who work at this level, then I'm always saying, is this the right term? Does everyone agree with that? Does that make sense? And as they get developed, is the terminology still correct? I find if I make a bug if I've got a bug somewhere, I occasionally have bugs. Hardly ever have bugs these days, but occasionally I do. Often I'll rename something and try and make it clearer because obviously there's something wrong in what I've expressed. And usually it may well be around the name of a method. It may be that I don't have clarity around a class. It's representing something in the domain. It's kind of got a bit big and it's feeling a bit awkward. And I'm talking to the product managers about this and they're saying, oh, gosh, you've lumped all that together. You know, we never intended that. Or they say, oh, well, that's interesting. There are distinctions in there that we've never really thought about before. You know, here, let's bring in this example and now we can start pulling things apart, changing the naming, rethinking about things. Okay, so I've kind of said most of what I want to say, but I've got a whole lot of slides. So test-driven development was developed by Kent Beck. His book came out, I think, in 2002. He talked about it early on in agile development. And when I first started, I'd always done example-driven development, but I hadn't developed tests. And I found this a very powerful technique. If you're a programmer and you haven't tried it, I really recommend you do. It looks weird because initially, well, tests are kind of something you'd prefer to put off because when you write, if you test something, then it's just going to show up the flaws you've made. But if you bring them up front and think of it in terms of specification and design, it really changes the way you program. And as I say, I spend very little time debugging now as compared to before I had tests. So concrete examples, developing the domain, and so on. So I probably don't need to say anything more about test-driven development other than it's a process of thinking. And I see storytest as very much a thinking tool, a way of expressing things as anything else. And if you have a notation which helps you express what you want to express easily, then it's going to help you communicate and think about those things. So there's, as well as tests at a programmer level, unit tests, there's all kind of issues around the business risk as well and around what should a system do. And this is why story tests, this was a term invented by Joshua Kiryevsky, and it comes originally out of the idea of a story, which is a unit of work within an agile process. So a story test is a way of specifying what should happen in a story. But I like the idea of a story test anyway, because each story test tells a little story. It's not very large, it's just focusing on one element, and it's very easy to see what it's about. And that these, step by step, these story tests accumulate and change as they go. So story tests, okay, around developing something, an idea of the domain, and they actually end up being a very useful business resource for thinking about things. Programmers need to write a little bit of code which make connections between the story test and the system under test. But I've almost finished in the next version of FitLibrary, pretty much eliminating the need for fixtures. So that's going to make a big jump in terms of how you think about story tests and how programmers use them. So this is kind of based very much on a domain-driven design approach to thinking. So I'm quite excited about that. I was hoping to demonstrate that, but it's kind of, I'm realizing now that there needs to be new tools to support this, which I'll say something about. So this slide's a little bit about the kind of things that you model in tables, and it's not obvious, and it would take a while to cover this, but essentially the ideas of domain-driven design and almost all of the patterns out of Eric Evans' book translate directly onto how do you do design at the story test level. So in his book, he really is talking about UML diagrams and discussions here and code there. And what I'm putting in the middle are fit story tests, which are developing the language and are mediating between these two areas. And obviously then that we need to be able to refactor and change names between the story tests and the code. So this is where the tools come in to make it easy to make changes at multiple levels. Sometimes the programmers are raising questions and looking for abstractions and refactorings. Sometimes it comes at the story test level. As well as I mentioned as constraints and calculations, which are abstractions of certain points. What can happen when? Who's allowed to do what? Rather than showing them through lots of workflow, extracting those out and showing them as individual things. So a lot of this is around noticing something, isolating it and being clear about it, and then be able to ask questions, have discussions about it. Are there other cases? Are there other constraints that apply in terms of submissions to a conference or whatever it might be? Okay, so domain-driven design, as I say, is kind of sits underneath my thinking about what story tests are about. To my mind, many people who write fit story tests are writing them very much as tests and not thinking about the domain. But I see real power in writing them around the domain, and mainly because it comes back to the principle of saying things once. And that is that if you say things in multiple times, then when you change your mind, it's a bit of a pain to have to change all those different repetitions of that idea. Now, the repetitions may not look very similar. They may be in quite different forms. So what I'm finding is that the story tests are a way of specifying the domain, and they can be used in a range of ways, not only in testing, but also in other forms. So the story tests, the very same set of story tests, could be used to test through the domain layer, as I said before, through subsystems, through the user interface, through dealing with performance and load issues, like automatically being used to generate large databases over which load performance testing can be made. And more recently, I've been working on using story tests, adding a little bit of extra information to the story tests. Okay, so the context is a customer who has an application which is generic. It's tailored by all the clients who use it to their currency, their date format, their dimmer format, et cetera, et cetera. Now, they need to provide help and online documentation, and the customers aren't very keen about just the mass of it and the fact that it's always showing examples in US terms, and it's not showing it tailored to their needs. The other thing is that every time the system changes, then all the screen dumps have to be done and all the documentation has to be changed, and it's a real pain to track that. So what I suggested, and this is working out very well, is to have the story test, and some of them have a little bit of extra information around what is happening in here. And now what we can do is automatically generate the help information for that system. Not only can we do that automatically, but the system does screen dumps of all the screens, and we can define what the screens are, and that the documentation can be generated dynamically based on the tailoring of the users who are using. So they are seeing examples based on the system that they're using. So that then means by having a common form for representing the story test and generating that, it means then that you can do continuous document generation and as well as support continuous changes to your database as the system evolves, and to be able to easily do performance testing.
Can you explain how you say story test in the UI? I don't get it. Where does the UI matching to the domain come in to help the story test drive?
Okay, so the question is, given a set of story tests, how do you test drive that through the user interface? Now, with Fit, there is a thing called a fixture, which is a little bit of code, which I'm mostly getting rid of, except in this case. And that is making a simple mapping between the story test and the system. Now, I have a set of story tests for the domain layer. Now I want to be able to test the user interface. So I plug in different fixtures, and what those fixtures do are essentially making a mapping from the domain layer into the UI. Now, what's really surprised me is the amount of code that has to be written there is very, very small. And you only write once how to do something within the user interface. And then if the user interface changes, there's only one point where you need to change the fixture to manage that. So it completely insulates the story test from the user interface. So I've done this generating Selenium, running dynamically Selenium, testing through Swing using, in fact, JFC unit. So, and I don't see any reason why it can't be applied to any arbitrary standard robot type approach or anything else as well. And I'm sure there are other situations where story tests could be used in other ways. Okay, so coming towards the end. So remaining challenges. Well, this is still relatively new. Some of the tools need to be improved. As we move more towards a domain-driven design perspective, I can see that story tests change. At the moment, if the terminology changes, then you have to go through and edit them in a very simple way. So I'm currently working on refactoring tools, a tool which will allow me to construct, refactor, and run story tests and support the domain development and automatically generate use cases in UML class diagrams and a whole lot of other things that people have worked on before. So that's where I think I can get to. So those kind of tools are kind of useful. The other ones in terms of supporting refactoring which are applied to story tests, such as extracting calculation rules out of a set of workflow rules. The other one is then looking at, come back to an early point, is what this tool turns into is a general purpose tool for managing table-based domain-specific languages. So there's kind of lots of interesting connections into other areas. Okay, so I've kind of brushed over a few problems and very quickly brought together the idea that story tests could play a role in helping to solve them. There's still some serious issues around, well, how do you take an existing system that doesn't have a domain layer? How do you gradually build the domain layer? Well, the story tests are going to help, but there's still issues around what is the domain, how do you get that understanding, and how do you evolve that? Concrete examples are key. Asking someone to give you an example is so powerful as a way of starting to understand things. And we use it all the time in terms of how you ask things. if I learn a new programming language, I don't want to read the specifications. I want to just see a few examples. Now, let me see an example with a for loop in it, or how does recursion work, or what is the class structure, or how does inheritance work, whatever it might be. Executable specifications, looking at story tests as saying what should happen as well as saying this has happened or not. Clarifying, a thinking tool, a communication tool, through domain-driven design, an alignment between story tests at a domain level and the classes within the system that are representing domain objects. And then using story tests for testing and other things in very general ways. Okay, so that's my message. The book that you have available to you covers a certain amount of that. Okay, so I'm ready for questions.
So, Jeff Miller met me a couple of times when I was working for somebody else before. Tell us about FitLibrary 2 and getting rid of fixtures. Fixtures were basically where the programmer had to be the adapter between the literate specification and tables and the implementations language.
Okay, so the question is, what is FitLibrary 2 about in terms of getting rid of the fixtures? The key to it is very simple, and it actually ends up being amazingly simple in some way, and that is that if the story tests more directly represent the domain, then there is no mapping between the story test and the underlying system because they are the same. And the story tests then become almost like a serialized representation of the objects, the domain objects in the system. So the closer there is an alignment between the story test and the system, the less the mapping. So the trick is to find a way in which to embed the story test so that you are talking within an OO context whenever you write a story test. And that's the trick that suddenly makes all this easy. So where the story tests don't map directly, as with Selenium testing, UE testing, then there is code that's written. But now that turns into a much more of a general mapping issue, and there's opportunity for using general mapping tools to do that mapping, so you're not having to write lots of code to map. Here is a piece of a story test. Here's an action that happens. What does that actually mean in terms of what does the user do? Select from this item, select this menu item, click here, and so on. Yeah?
Can this script tool be, how easy is it to link with C++ or other libraries to call from reference?
How easy is it to use this with C++? There is a fit version of C++. C++ is kind of awkward because it doesn't have, fit relies on reflection. And so with languages that don't have reflection, it's harder to provide the support for them. FitLibrary has been ported to C# and to it's being ported to Ruby and it's been Python for quite some time, Smalltalk. No one, well, Michael Feathers talked to me about porting FitLibrary to C++, but I think it won't be easy. I'm not sure if that's the fundamental part of your question, but once the tools are set up to make it possible, then the story tests are language independent. And it means that once you have the story tests developed as part of the implementation, if you decide to shift your platform, then the story tests are the resource that remain. And then you can continue to port them. So that's the way in which FitLibrary has been ported. People have used my story test for FitLibrary to then develop in a different language. Yeah?
C++ compiler that uses XML to generate an XML description of all the code. So then that's your introspection. You sax it in or dump it in, and it boosts library.
Okay, right. Okay, so there's no reason why this can't be supported.
It's not dynamic upfront time. It's pre-introspection.
Yeah, but you just run it. It just happens. It takes like you have it at your separate phase. So that's no big deal. Yeah. Any other questions? Yeah.
I'd like to build on Jeff's question a little bit. Because I think you're correct that if your domain layer uses the ubiquitous language, the fit tests sort of very much use the same vocabulary, but I think there's still challenges sort of on the structural side of things, because to me a nice domain layer benefits from sort of fine-grained, nice object graphs, a lot of interrelationships, whereas it seems the tables benefit more from sort of coarse-grained actions, no control structures, no life cycles, and I think there's a potentially little mismatch on how do you overcome that.
Yeah, I think there's two answers to the question. One is that, I just showed you one example. One is that I kind of want a notation which allows me to express a whole range of things. And sometimes a table is not it. Tables are good for very simple hierarchy. But certainly there are graphical forms which are better represented elsewhere. I think in time, the stuff that I'm doing, tables will just be one way. So I kind of allow for trees and graphs and general images as well. So it's possible to use a whole range of ways. So I kind of want to push this into essentially the domain-specific language allows you to build visual languages to describe what you want. But that's a fair way off. The other one is around, well, what things can you express easily and what not? So we may have a set of story tests. The way I think about workflow is that there are state transitions within a state transition graph of the system, and that what we're doing is describing each of the important transitions using examples. And if we set that up in a particular way, then we can focus on here are a set of states of the system, and here are transitions, and we can define what we expect. So then we can share the states between tests. So this test includes this state as a starting position and this state as an ending position, and then I can include this ending position state here as a starting position for another. So it now has it. So I've set it up so it has the same form. So now I have a graph of these transitions, and so it would be useful to have ways of pulling out pictures of that and to see, well, what is the relationships between those? And what comes out of that, I think, are use cases, because use cases tend to be at a grosser level normally than story tests. So that's kind of one example. The other one is in terms of at the domain level, what are the associations between objects? And again, at the example level, normally with tables, that's kind of implied. It's never explicit. So the refactoring tool that I'm building is fundamentally building everything at an example level, but it constructs the domain. So it's actually constructing a domain underlying it, and that's why I will be able to generate UML class diagrams and such like. So I think part of it is to see what are the techniques that other people have used, flow diagrams, use cases, class diagrams, object diagrams, all of those things. I think those things can be emergent. The other part of it is in terms of emergence of UI out of domain as well, and that's another area in which I want to push it. So I think there's a lot of really interesting, challenging issues around that. And if you have particular examples of issues that come up, I'd love to hear them. I'm a great fan of examples and of challenges. Any other questions? Well, thank you for your attention and patience. Thank you.